Okay, hey everybody. So today we're going to look at a classic physics elevator problem. One you'll see in like a AP Physics or high school physics class. It goes something like you're on a bathroom scale, standing on a bathroom scale while riding an elevator. As it goes up to a higher floor, what will the scale read? What will your weight say? Like why would anyone ever do that in real life? I'm not sure, but it's one of those physics problems that you see a lot in class. So anyway, here we are at my school, and we're gonna start at the sixth floor and go down, and we're gonna see what happens. So we're gonna use a LabQuest 2. A lot of schools have this for physics class made by Vernier. They don't make these anymore, they make a LabQuest 3. But the LabQuest 2 I think is much better because it has a built-in accelerometer. Among many of the built-in sensors, it has the accelerometer in all three axes. So go ahead and turn on the accelerometer in the z-axis. And this is how you would do it in the setup menu. Okay, and Z is for Z-axis. That is the axis of the machine that goes through the screen. Like through the screen and through the back, that's the Z-axis. And what's true about all these accelerometers is they kind of indirectly measure acceleration by measuring actually a normal force. Inside there's a little spring, or you could think of it as tension, but I think it's easier to think of it as normal force. And the proof is when you put it sideways, like this, it's not accelerating, nothing is pushing on the back of it. But then when I lay it flat, there's something pushing on the back of it, right? To hold it up, that's the floor, and it actually senses that, right? So here you can see it says 9.8, and you'll be like, oh, it's sensing gravity. Gravity's 9.8. Yeah, that's true. But really, it's sensing the opposing normal force and the acceleration associated with that, right? So here, while you're lying at rest, it should say 9.8 because it is equal to the force of gravity. Normal force is equal to the force of gravity, so you see the same acceleration value. What's going to happen is I will put it on the floor of the elevator, like so, as we go up and down the elevator, and it can graph, and the graph will end up looking something like this. And you might think, hey, I don't have a LabQuest 2. You can actually get a lot of free apps that have pretty much the same exact thing. An accelerometer in different axes, like a z-axis. You can get it through an app called Sensor Kinetics or Fifox. They're free, and they'll just go right to your smartphone. Basically does the same thing, even graphs, so it's actually pretty cool. Okay, so I hit the first floor, and we're going to go down from 6 down to the first floor, and let's see what happens. And the first thing you'll notice, so we're going to look at our accelerometer, is that it's going to drop. It's going to drop to a lower value, almost 8 point something, and then it kind of evens out to about 9.8 again, and then it kind of rises again to like 10 point something, right? See that? Okay, so first let's explain the downward part. While descending, you're accelerating downward. The net force is downward, so your down force, Fg, or force of gravity, must be greater than the up force, normal force. Normal force points up. Fg is straight down. Always straight down your mass times 9.8. So let's say my mass is 60 kilograms, like we saw in the beginning. My 60 times 9.8, Fg, would be 588 newtons. If I'm accelerating downward, the downward must be greater than the upward to give me a net force down. So the up force, the normal force, must be a little bit less than 588. And the proof of that is that the acceleration that the sensor, the LabQuest sensor, showed you was less than 9.8. It was something less than gravity because it was feeling something less. The normal force must have gone down. That's what it senses. It's sensing a lower normal force all of a sudden. Okay, then what about later? Why would the acceleration on the LabQuest sensor show something higher than 9.8? That must mean the opposite. So if it goes down and it says like 8 point something, that means the normal force is less than my Fg, my weight. But if it says 10 point something 11, that must mean the normal force I feel is greater than my Fg, my weight. Okay, remember your weight is your Fg. That's always 588. 60 times 9.8 using my mass here, that will not change. The Fg will not change. But the normal force can change. Now it can be greater. So this will happen as you go upward and as you ascend, or it could mean when you're slowing down on a descent. You're going down but then slowing. That means your acceleration is upward, and the normal force then will be greater than your force of gravity. Okay, and when you're done graphing, it'll show you something like this. Let's go over it real quick. This semi-flat part around 9.8, right around 9.8, that's when you're at rest, like you're waiting for the elevator doors to close or something. And then this part, the acceleration is lower than 9.8, meaning the normal force, again, the sense is normal force, the normal force is less than your force of gravity. That's when you're accelerating down, either starting your downward journey, going to a lower floor, or as you're heading up, slowing down as you're heading up. Okay, and then this part is a greater normal force. So you see a greater acceleration listed from the LabQuest. That is when your normal force is greater than your FG while you head up, or you're slowing down while heading down. Okay, those both will give you an upward acceleration. And then here again, you have a nice and flat part around 9.8. This part actually is you're on the elevator between floors moving at constant speed. When you move at constant velocity, that is also zero net force, where your normal force will equal your force of gravity.